So today I'll be talking about inductive charging and explaining the core concepts and components of it. So, what is inductive charging? Inductive charging is a wireless power transfer method using electromagnetic fields to charge devices. It eliminates the needs for physical connectors by transferring energy through coils. So, some of the basics of inductive charging. Inductive charging operates on the principle of electromagnetic induction, where there are alternating current in the transmitter coil, as shown in the orange coil on the image. Uh, and this field induces a current into the receiver coil, as shown in the yellow coil, converting magnetic energy back to electrical energy to charge the device. There are generally three types of inductive chargers: Q wireless charging, resonant charging, and radio frequency charging. uh, so let's start with Q charging. It is the most common type of inductive charging. It uses electromagnetic induction. Almost all modern smartphones today support wireless charging. Use Q wireless charging. Second, resonant charging. Resonant charging it works by tuning to the two coils, the transmitter and receiver coil, to the same frequency. This will make both coils oscillate and transfer energy much more efficiently. And this effect also allows for the device to be charged from a much further distance. The last type is radio frequency. And this is unique because it uses electromagnetic waves instead of a magnetic field. This allows for, and this basically means that the transmitter coil turns electrical energy into electromagnetic waves, which the receiver coil then receives, and then turns back into electrical energy. And this allows the device to be charged up to many meters away, though it's less efficient and slower compared to the other two types. So the history behind inductive charging. Nicholas and Tesla was one of the first scientists to discover inductive charging, and he did this while working on his high frequency alternating currents systems in the late 1800s. He kind of applied this in 1891 when he invented the Tesla coil, a high frequency resonant transformer. He later tried to scale the idea with the Wardenclyffe Tower, but it sadly did not work. So, some applications of and benefits of inductive charging. So it's used in electrical vehicles now, and it's one of the biggest emerging uses of inductive charging, especially as electric vehicle adoption grows. And basically, it works with a charging pad that has a transmitter coil and a receiver coil in a electrical vehicle. It's also used in smartphones, as I mentioned before, with Q wireless charging. It's also used in medical implant devices to reduce the use of surgical procedures to, recharge devices such as pacemakers for the heart. It's also used in autonomous underwater vehicles to reduce the need for using actual wires, which could lead to water getting into the ports. And it's used in everyday devices like electrical razors, toothbrushes, power tools. Some advantages of using inductive is that it eliminates the physical need for physical connectors. So there's no exposed metal contact, reduces wear and corrosion and mechanical failure. It's ideal for wet or harsh environments. It's more enhances safety because there's no open electrical terminals, lower risk of shock, and it's safer in bathrooms, outdoors, medical settings. And it reduces maintenance because there's no plugs to break in or cables that could be frayed. It's a generally longer device lifespan and lower repair costs over time. But there are disadvantages to inductive charging. So it's inefficient compared to other methods of charging because energy is lost as heat during magnetic transfer. And this aspect was shown in my demonstration when the wireless charging was nearly 5 degrees warmer than the wire charging, which demonstrated that a lot more energy was lost in the form of heat. It's typically less efficient than wire charging by around 20% and loses about half the energy it receives when transferring. Again, it was demonstrated in my demonstration that it took over double the time for wireless charging to power the same phone compared to wire charging. It's also sensitive to how it's aligned its poor position, it reduces the speed and efficiency of the charging. Um, and then there's generally higher costs and heat generation pose like limitations for widespread adaptation. And this is due because the heat generated or energy lost can affect battery health. So in conclusion, inductive charging represents a significant advancement in wireless energy transfer and offering improved convenience, safety, and durability for modern devices. It enables innovative applications in smartphones, electric vehicles, medical implants, etc. And while challenges such as like efficiency, limitations, alignment sensitive, and higher costs remain, ongoing like technological advancements continue to expand its applications and enhance its efficiency. And as engineering improvements increase power levels and efficiency, inductive charging is positioned to play an even greater role in the future of wireless charging systems. Thank you.